Right, so as I said, right wave function, it's basically looking about how we can combine expressions that contain sin x and cos x. So we're going to look at a little PowerPoint that will take us through this. I will post the notes that go with this, but this is just to quickly introduce you to this. So supposing we wanted to compare these graphs, we would be looking at the right, we would be looking at each of them individually. So hopefully you know what the sine graph looks like, hopefully you know what the cos graph looks like, but it's then what happens when you add them together. So your sine graph, your nice wave that you've got there, goes up to 4, down to -4. Your maximum, these sort of things are, these are things you'd be expected to know. Minimum when it's at 270 and so on. Your cos graph, slightly different but still a wave function. It's more like that, starts off like the Big Dipper, so it starts up at 3, and again knowing when it's at each of these points is the sort of thing you'd be expected to know for that. However, when we combine and add them together, if you were to work out, and I gave you a whole load of angles to do, if we had time to do this, I'd ask you to work it out and to have a little sketch, right? But we don't have time to do that, even though we're not doing the whole course, right? We still don't really have time. What you'd notice this time when we add them together, you might have thought, oh, maybe it goes up to 7, but it doesn't actually go up to 7. It is still a wave, but it's like a cos graph that's been shifted a wee bit to the right. So, because normally the cos graph would start right up here, right? But it's what we call the phase angle, where it's shifted a wee bit to, as I said, to the right. So, in terms, you're not expected to be able to draw this or sketch it just now, but it is roughly as if it's been shifted about 50 degrees to the right. But in actual fact, right, it's these values down here at the bottom, the 53.1, the 233.1. By the time we've finished today's lesson, you will be able to work out these values. So, as I've said, when you add a sine and a cos together, it produces a new wave. That's what I want you to see from here. That new wave can be written, and you'll see we've said it's the same thing as having a single cos expression, but it's a cos that's got what's called a phase angle, which is a shift. So it's sort of like the cos graph shift to the right. So what do we aim to do with this? So we aim to convert from a mixture of sines and cos to just cos, and you'll also see that we can convert it to just the sine, but basically because it's easier to deal with when you've just got one function there. So rather than a mixture of the sine and cos, you create one single function, and that function is known as the wave function. So from today's lesson, we will be looking for you to go from y equals a sine x plus b cos x, so there'll be numbers where a and b are, and we will only focus on the first one here, but basically there are 4 different options, and in terms of an exam question, they will tell you which one you are going to be using. And what we do is, by considering the trig addition formulae and comparing coefficients, we will be able to prove the angle, those values that I was speaking about, the 50 and the being able to get the exact ones. We will be able to work those out. So, going back to my Smartboard file, and I've put the trig formula here as a little reminder. That's what we will be using. So this is in your notes, right? So the first inside, you've got your title page and so on, and then inside your notes you've got this on page 176 if you've collected them, and it's saying an expression of the form p cos x plus q sin x can be written as this single cos function. And that cos is a wave function, and it's got a phase angle, right? So this little bit here is what you're going to be working out, and you're also going to be working out this. Now, don't learn this bit at the top here because it doesn't help you. What will help you is the process. So don't write learn or anything beside that top bit. These questions are worth 4 marks. That they can sometimes have a B part, which we will move to later on. But you've got this down the left-hand side. So it's saying write 5 cos x plus 12 sin x in the form of a single cos expression, where your angle A is between 0 and 360. So here's what you need to do. I will post this anyway if you don't get it all written down, but if you're not sure about anything, ask at the time. So first step says expand k cos x minus a using the compound angle formula. So you should always write down the equation, and then you write down equals, and then whichever expression they've told you to write it in. So here it's a k cos x minus a. You are now going to use, so this here, the k cos x minus a, you know how to, that's your cos x minus, that's your cos a minus b, right? So you're going to go to your formula sheet and you will be looking for the cos of a minus b. Now that's the one that's got the cos, and then the cos one always goes on the opposite sign, so it's got a plus in it, and then you get sin. However, we've got a multiplier of k at the front. So, yep.
I can't see your screen now.
Can anyone else not see the screen?
Yeah, I can't see it either.
Try again. So I've stopped sharing. We'll try again. Okay. Can you see yet?
Not yet, no. Oh, now I can. Now I can.
Yeah? Okay?
Yeah.
Right, we all right now? Right. So we're using the cos a minus b formula to expand. That would give us cos x, cos a, and then plus sin x, sin a. But we've also got a multiplier at the front here of k. So notice that that k gets written in front of each of the cos, plus sin, sin. Right, that's your expansion. When you expand cos a minus b using the formula, that's what you get. So this is standard practice, and just get into the habit of writing that sort of thing out, those first 2 lines. What you then need to do is, because we're going to be equating the left-hand side and the right-hand side, you will notice that on this one, we were looking at we've got a cos x term here. So here's my cos x in here. What's round about my cos x is a k cos a. So I've put them to the front together. So there's my cos x here, and I've got my k. All I've done to go from this line to this line is I put the k cos a at the front and said that's my multiplier, and then I've got my sin term. So I've got my sin, there's my sin x, here's my sin x here. What's round about the sin x is k sin a, so that goes in brackets. And there's your sin x here. Now you want to, now I've written it down underneath just so you can see, because you're going to match it up. Highlighters can sometimes help you with this sort of thing, so that you can see what it is that you're doing. So anything that's multiplying the cos x, which in this case is 5, needs to match to cos a. Anything that is multiplying by the sin x, so here, needs to match to that. So what that does, right, is that, so this step 2, right, rearrange to compare with p cos x plus q sin x. So that's this bit. Part 3 compare the coefficients, and that's what we're doing, and then from that compare coefficients, you form two mini equations. So what we write down is that k cos A needs to be equal to 5 and k sin A needs to be equal to 12. Okay, so that's us down at step 3, where you compare the coefficients, and when you produce these two equations, right, that's what you get. You get a mark for writing both of those down. So watch the signs and so on. Now this next bit sort of splits into two, because you need to be able to work out the A, which is the angle, and you also need to be able to work out the k value at the front. So step 4, it doesn't matter actually which order you do step 4 and step 5 in. Step 4, you are going to put together the two equations that you've got here. Now we know
Miss,
from trig, yep,
Did you scroll your screen down to see like step 4 and that?
yep.
That is froze again then. It might just be my laptop though, 'cause it's been
I think it maybe is,
Alright.
unless anyone
It's the
else
same
has
for
got,
me as well. It just seems to freeze.
I don't know why, sorry, can't help you with technical issues. I will, like I say, I will,
in physics, if they leave and join back in the call, it should fix it.
Yeah, I'll try that then.
Right.
okay, right, so for the working out the angle, you need to be using your identity that says sine over cos. So you put the sine of the angle over the cos of the angle. Now we've still got the k there, but technically the k's will cancel each other out. So actually if I write these two numbers over each other, I'm just actually writing sine over cos, and sine over cos is actually equal to tan. That's one of your trig identities. So you always take your two equations, you will write tan of the angle equals your first fraction k sin A over, make sure you've always got, it doesn't matter what order you've written them in, but you need the sine on the top, cos on the bottom, and you write down what you've got. And then from that, you then need to go into your CAST diagram. Now everything is positive here, the sine is positive, cos is positive, so if you were marking everything off, the one that's got all three ticks in it is the all, which means it's the first quadrant. So basically all you need to do is go to your calculator and you do tan to the minus 1 of 12 over 5. That gives you 67.3801, whole load of figures, and we get 67.4. Any questions about that bit? I know there's loads of writing and stuff on this, but I will print it so you can have another look at it. But what you would be writing, you're not writing all the writing. You would just be writing tan A equals k sin A over k cos A equals, and then put your two numbers, match it. CAST diagram, so you know what quadrant to look for your angle in, and then you do this little calculation. So that's how you work out the angle for our wave. So what we've been able to work out here is this. We now know that this cos function has been shifted to the right 67.4 degrees. So coming back to the two equations and looking at step 5. Step 5 says find k and A using the formula and above. It says A lies in quadrant, we've already spoken about that. So this is why I'm saying 4 and 5 kind of overlap. Now, this next bit I'm going to talk you through, but you will be able to jump down to, I don't know if you can see where I've got square and add. If you write that underneath, so draw in like a little line, write in square and add. You don't necessarily need to write the next two lines of working I've got here. I just wanted to show you or explain to you why this works. If we square k cos A, we get k squared, cos squared A, and we would get 5 squared on the other side. And if we square k squared and sine squared A, so that we're seeing these a bit like doing simultaneous equations. And if you square everything there, you've got a common factor of k squared, that comes out, and what you're left with in the brackets here is cos squared plus sine squared. And cos squared plus sine squared is always equal to 1. That's the other trig identity. But you don't need to remember that. What that then produces is the fact that to work out the k squared value, it's just simply going to be each of these squared. So these two lines here, right, you don't need to put them in. I've just put them in by way of explanation. Right, so this little bit here, right, is, I'm going to say, non-essential, so don't, right, that's just explanation. It's not anything that you need to worry about writing anything like that out. You come down, square and add. If you write that in for yourself, you remember what to do. You get down to k squared equals 169, k equals root 169, and you get the value for k. So now that we've worked out k and a, at the bottom for step 6, you can then write down, there was our original wave, 5 cos x plus 12 sin x. If we add those two functions together, we get a new single trig expression, which we can write like this. 13 was our number at the front, our k value, and you've got cos x minus 67.4. Any questions? It's pretty hard looking all this stuff when you see it the first time. I think when we work through the next one together, you'll get into the way of writing out your working for this sort of thing. So I'm going to move on. So this one here is your first example that doesn't have all the steps down the side. No, that's the one we've just done, not this one. Actually, I'm going to do this one with you, which is the two. We're going to add this in. So I don't know whether you got your notes have got a blank sheet this time or whether they're double-sided. If you've got room, put it on the notes. If not, put it in your jotter. We're going to do this exam question, and I'll show you how you get the marks for a question like this. So it tells you in the question to express this 2 cos x minus sin x. So 2 cos x minus sin x equals to k cos x minus a. So that's how you would set it up. Now what we need to do is we expand, right? So we use, and if we were looking up your notes, you would look up this formula in the exam. You'd go and look this up. So you've cos A, cos B. Remember, if you've got minus, it's going to be plus, right? And it gives you sin A, sin B. So for us, what that means is we've got the multiplier. You need to put the cos in. So you get cos x, cos A. Then you're going to have plus k sin x, sin A. Right, now check in the order that we've got. We've got a cos x term first. Here's my cos x in here. So what's round about that cos x? I've got k cos A, so that's like my multiplier. So k cos A is multiplying my cos x. And then if I check my sin x term, here's my sin x in here. And I've got k sin A multiplying that sin x. So now what I want to do is make sure, right, there's my cos x, there's my sin x. And I want to make sure that left hand side and right hand side match. Now I'm just going to write this down underneath just because it makes it easier. Right, so you are comparing so that you can match up. You've got 2 cos x, you've got minus sin x. Now, as I said, highlighters can sometimes help you with this. So whatever is multiplying cos x, which in here, right, they need to match. And then for the sin x, we've got this. But what's multiplying the sin x here is just a minus sign. So, over on the left here, right, I'm going to write, and this is where I would usually write it. I would write down that what I'm doing, right, equate the coefficients. And I'm going to write down my two mini equations. So I get k cos A equals 2, and I get k sin A equals negative 1. I'm just going to have a quick look. Are they back in the call?
Yeah.
Yeah. Right, okay. That's fine. Who was the other one? Who else had an issue?
Gloria, I think.
Right. Okay, so equating the coefficients, we've got k cos A equals 2, k sin A equals minus 1. So this is your two little mini equations. It doesn't matter what order you work out the k or the A in. I'm going to say work out the k first. And we do that by, if you just write underneath that and say square and add. Get into the way of writing that down. All you basically need to do after that, just make my page go up a wee bit. So we would write down that k squared will be equal to each of these numbers squared and added together. So that means that our k squared would be 4 plus 1. So k squared would be 5, which lets you write down that k will be equal to square root of 5. And then from that you need to work out the A. Now to work out the A, this is where you use the tan. And the tan of the angle will be equal to sine over cos. So if we put k sine A over k cos A, right, the k's effectively cancel each other out. So we will have, and make sure you get it the right way round, so negative 1 on the top, because that's what sine A is equal to, and on the bottom the cos A value, which is 2. So you're now going to try and solve this. So in order to do that, you need your cast diagram to make sure you get the angle in the right place. So let's go through and tick off what do we know. So we can see clearly from the first equation, cos is positive. So cos is positive means first quadrant or fourth quadrant. In the next equation, you can see you've got a sign that's negative. So where does the sign being negative happen? And the sign being negative, right, happens in the third quadrant and the fourth quadrant. And then what else can we see? We can see that the tan is also negative. So where does that happen? So the tan being negative happens in the second quadrant and in the fourth quadrant. Now the one that's got all three ticks in it is the one where you are going to find your A, right, will be in the fourth quadrant. And you can tell that from go through each equation in turn. So of course, to find the angle in the fourth quadrant, you need to first of all ignore the negative and look for the first quadrant angle. So first quadrant angle, you will do tan to the minus 1 over half, right, and tan to the minus 1 of positive a half gives us 26.5650. Hold up the numbers, we'll call it 26.57, or you could round it to 26.6. Doesn't, if you can use 1 or 2 degrees, but don't go to the nearest degree unless it tells you. So fourth quadrant angle would therefore be 360 minus that 26.57. So we would be looking for 333.43. Okay, so key thing, do the cast diagram, decide which quadrant your angle is going to be in, and you go through each of the equations in turn. Once you've got that and you've worked out that A is therefore that 333.43, and the final part of this is that you can then write down the original equation was 2 cos x minus sin x, and that is equal to square root of 5, and it was cos x minus that A angle, 333.43 or 0.4 if you went with it. Any questions? Okay. Going to show you the marking scheme. So this was 2018 paper, and this is what you get a mark for. So you get a mark for using the compound angle formula, so you need to state that explicitly, so you need to multiply that out, and notice the fact that the K needs to appear beside both the terms. Then we've got compare coefficients, so that's your two little equations. They need to be stated explicitly. Okay, and my advice is write them one underneath the other. Then you need to work out your value of K, and then the fourth mark, process for A and express in the form. So once you've worked out your angle, you need to do that last bit, so you wouldn't want to end up losing the last mark from not filling in the angle. Okay, so any questions?